Now let's recap what we have. FFT is computing the product of this matrix capital M times little a. And that's outputting capital A, which is the value of this polynomial at these nth roots of unity. For inverse FFT, we want to do the reverse. So we want to compute the product of M inverse times capital A and get back the coefficient vector little a. Now we claim the following lemma, which we'll prove momentarily. The inverse of M is 1 over n times M of omega sub n to the n minus 1. So we take the same matrix, instead of parameterized by omega sub n, we parameterize it by omega sub n to the n minus 1, which is just a different root of unity. So let's take this expression, multiply both sides by little n, and then substitute in M inverse with this quantity. So we have n times little a, and then for M inverse, we replace it by this quantity, M sub n of omega sub n to the n minus 1 times capital A. Notice this corresponds to an FFT computation. In particular, we run FFT with, instead of using input little a, we use input capital A. And instead of using omega sub n as the nth root of unity, we use omega sub n to the n minus 1, which is also an nth root of unity. Now it's quite intriguing what's happening here. We're taking the value of this polynomial a of x at the nth roots of unity, and we're treating these values as coefficients for a new polynomial. Now we run FFT for this new polynomial, and instead of using the nth root of unity omega sub n, we're using this nth root of unity. It's still an nth root of unity, so we can again run FFT. So we run FFT with these two inputs. We get back a vector which we scale by 1 over n, and this gives us the coefficients for our polynomial a of x. So we can go from the values at the nth root of unity to the coefficients. One more intriguing fact before we move on to the proof of this lemma. Now FFT, normally we run it with omega sub n. This is this point right here. Then the endpoints we consider are omega sub n to the powers, which corresponds to the nth roots of unity going from 1 to omega sub n, and so on around the unit circle in this manner. So we go counterclockwise around the nth roots of unity. Now what happens when we run FFT with omega sub n to the n minus 1? That's this point here. Now the only difference is we're going over the same points, but we're going over them in different order. Now we go over the nth roots of unity in clockwise order. So inverse FFT is the same as FFT, we just go over the nth roots of unity in the opposite order. That's the amazing fact. And we can use the same algorithm as we detailed before, because when we detailed the FFT algorithm, we allowed any nth root of unity there. Now we'll prove the lemma, and that'll complete our polynomial multiplication algorithm and our convolution algorithm.